What you're about to hear is a Pulte-sponsored webinar that aired Thursday, June 13th at 11 a.m. Central Time. Enabling the Next Billion Things, IoT Innovation Pillars that Drive Success is a webinar moderated by Daniel Collins, the former CTO and co-founder of Jasper. Listen as he moderates a team of IoT thought leaders, including our very own Pulte CEO, Ed Chao, in a discussion on enabling the next billion things.
First of all, thank you everybody for joining. My name is Daniel Collins, and I am the moderator here. So this is a webinar series where we're going to talk about all things mobile IoT, looking at use cases, trends, and so on. So the intention is that every month we'll have different thought leaders from different industries in the world of IoT to discuss what they're seeing and the challenges and solutions we see to enabling the next billion things in IoT. So as mentioned, my name is Daniel Collins. I am joined today by Blake Fuller, the CEO of GoPuck, Pierre, the CTO and General Manager of GeoTraq, and Ed Chao, the CEO of Polte. Before we get into the meat of the discussion, we'll all introduce ourselves, but prior to that, what I'd like to encourage our attendees to do is to submit questions online. So you can do this through Zoom. So if you have questions, please do submit them, and we'll have a question and answer session towards the latter end of the session. So let's get started. So to start, what we'll do is we'll take a minute or maybe 90 seconds to each introduce ourselves before we get into the discussion. So I'll start. I'm Daniel Collins. I was the co-founder and CTO of Jasper. We started Jasper in 2004 with the aim of making it easy to connect devices. This was before anybody had heard of the term IoT, before it was sexy. But we built a platform to make it easy to connect these devices, and we ended up connecting many millions. Jasper was acquired by Cisco in 2016. I stayed on after the acquisition. I continued as CTO within the Cisco IoT business unit. And by the time I left Cisco at the end of 2018, we had 115 million devices on the platform that we started. So that's me. Blake, can you introduce yourself?
Yeah, so hello everybody. My name is Blake Fuller, and I am the current CEO of GoPuck and one of the founders. But before I started GoPuck, just a little bit of my backstory is that I had a battery company that served motorsports, military, and medical batteries. And I got into that not because I originally was a battery expert, but I actually was an avid car racer and automotive enthusiast. And while racing my car at Pikes Peak Hill Climb back in 1998, I realized that the world of batteries had not evolved very much in over 100 years. We were driving a car that was very technologically advanced, but the battery itself was kind of the laggard of technology. So it struck my curiosity. I wanted to know more as to what's involved in making the next generation batteries. And in one of those 11-year overnight sessions, I had Rail that became the first company to ever produce a lithium-ion starting battery, and is now the current supplier for every Indy car you see racing, the championship Formula One cars. And as you can see, there's many first inventions that we had the pleasure of creating for our customers. And as we transition to what we're going to talk about, when we went from doing automotive products into consumer electronics and into powering IoT products, there was a lot to learn and a lot that we found challenging when it came to adding location services.
Excellent, thank you, Blake. Pierre.
Yeah, good morning, everybody. So my wireless experience goes back to the mid-'80s. I've seen all of the technology evolutions from amps all the way into our introductions now into 5G. So seen a lot of technologies come, seen a lot of technologies go, but one of the things that's really interested me is trying to take technologies and use them to solve customer problems. And I think the Internet of Things provides a playground for someone with my background to merge wireless technologies and location technologies and drive those into simple solutions that are easy for our customers and partners to implement. So at GeoTraq, really our goal is to simplify implementing IoT solutions. We think the complexity that we see in the marketplace today is really limiting and inhibiting the growth of the IoT, and we plan to change that as we move forward.
Excellent, thank you. And Ed.
Thank you, Daniel. I'm Ed Chao, CEO of Polte. I've been in the wireless industry now for a couple of decades, and one consistent theme throughout my whole career has been really bringing technology to improve people's lives and make the world a better place. But in particular, starting at Nortel and Lucent Technologies, bringing in 2G, 3G to the masses, and connecting voice and data, and then joining one of my favorite customers, Metro PCS, to actually run the equipment I sold them as head of engineering and operations. And in that, it was really about bringing simple, affordable, predictable wireless to the masses, right? We were the first to bring unlimited flat rate taxes and fees included to the United States, and really, really helping to bring affordable wireless to everyone. And then I joined as CEO at most recently at here at Polte to do something similar, which is to bring IoT and to focus on IoT. Right? We've connected people, but the next thing is about connecting Internet of Things to the internet as well, and being able to bring great location to enable that. So here at Polte, that's what we're doing. We're bringing great cellular-based location that is truly going to transform and help connect and be a fundamental pillar towards connecting the next billion things.
Okay, great. Thanks, Ed. So we're going to get into the meat of it now, and I'd like to start off with a thesis that I hold, at least. Obviously, I'm a big advocate for the Internet of Things. The promise of the Internet of Things is huge. But when you talk to people about the Internet of Things, we hear a lot about everything will be connected, we will extract all of this data, we'll apply artificial intelligence and machine learning, and we'll create insights and drive business value. And that's all true. But if we're going to do this at massive scale, billions of devices, then there are fundamental things that I believe we absolutely have to get right. The first is that connecting these devices and the modules, the fundamental connectivity has to be low cost. You can't connect billions of devices if it's going to be expensive to do so. So that's the first thing. Many of these devices will not have access to a power source or a reliable power source. So we're going to have very, very long battery life. And thirdly, we're always going to need to be able to know where these things are. We're talking about assets, possibly billions of assets, and we need to be able to locate them indoors or outdoors, anywhere on the planet. So now that's my view. I'd like to kick off the discussion with you, Blake, and get your take on this, and whether you agree with my view or not. Maybe we can start with understanding the challenge that you were facing and how it ties into what I just said.
Yeah, happy to help. And, obviously the terminology, as you mentioned from your background, you've been around before. It was called the Internet of Things. It just happened to be things or devices that you were somewhat connecting and starting to learn more information about. For us, with our battery background, our technology, when we were working in automotive space or even military space and medical space, the vehicle or the device we were powering, we actually had an advantage in the fact that we knew where and when and what type of environmental conditions we were going to design a battery for. So, for example, an Indy car, we know that it's going to go to select tracks around the country. We understand the times of day, the places, the time of length that it's going to be used for. All of these are taken into account. If it's a medical application, we understand that whether it's something in the OR or if it's something that's going to power bedside, we kind of understand the environmental conditions as well as exactly what type of requirements that product has to be built for. But when we jump into the Internet of Things, I kind of think of it more of as the Internet of Nouns. And a noun is a person, place, or thing, right? And the thing is actually very definable. It's the place and the person that makes it very, very difficult for us to design to. So if we think of what GoPuck is doing in inventing wearable power solution, that person is extremely important, and the places they go to are often unknown. So we wanted to help kind of define that scope of our product requirements by learning more about where, when, and maybe even who is using our product. So a couple of use cases to be very specific. We actually had pioneered the use of our products as a service rental solution for powering dead cell phones at theme parks, events, at some of the, should I say, famous venues that people go to be able to solve the, oh my goodness, my phone's dead, or my action camera's dead. The challenge is that in renting out that asset to a new unknown individual, we can't always validate if that person's returned it or if they love the product so much that they took it home. So we really had upon ourselves a challenge of being able to, one, know where our product is so that we could solve the Internet of Nouns, but also challenged in the fact that we are a battery solution. So nothing worse could happen to us than adding in a technology that's going to make our performance less.
So, so then you reached out to GeoTraq, is that right, to try and help?
Yeah, interestingly enough, we had met them at a mutual event. And at that particular point, one of the things that first drew me to the solutions being pioneered by GeoTraq were the size and the efficiency. And for us, that was very important because our product that we have, which is smaller than the palm of your hand, is very well known for providing a lot of power in a small space. So it's very energy dense and very power dense. And any type of additional feature set that we add in, we didn't want to break the form factor, so to speak. We didn't want to ruin the customer experience. So those were the key things that drew us to GeoTraq at first. And it's been great working with them. And of course, I'm sure Pierre will want to share a little bit of their side of the story as well.
Yeah, sure. So thanks for that, Blake. Yeah, so it's been fantastic working with GoPuck because they've been an early believer in what we're doing at GeoTraq. And what we're finding as we get involved with testing with them is some of the early concepts behind what we were doing with our connectivity modules actually play very well in the real world. So our modules are designed to be very small, which allows us to really focus on a couple of things. Daniel, as you mentioned, reducing cost, reducing power consumption are probably two of the key attributes that we're pursuing. Power consumption is largely talked about in the IoT today. You see many claims of 10 years of battery life, and today we're not really seeing anybody achieve that. But we have a very aggressive goal at GeoTraq. And as I tell my engineers, power conservation is priority one for us. And that requires us really to attack at multiple levels, to attack at the hardware level, to attack at the firmware level, and really the network interface level. All of those have tools that allow us to reduce power consumption. There's no silver bullet. It's going to be a compilation of many different things. And we are working through various combinations to try to optimize that solution. One of the things was key to us to be able to do that was to partner with Polte. It's impossible to really optimize battery life when GPS is being used. It increases the size of devices. It increases power consumption. The cost goes up $3-4 a device as you add GPS in, and ultimately the size gets bigger. So where we have created a module using Polte for the tracking layer, it's a self-contained package, different than many modules on the marketplace today. that require you to spin a printed circuit board, solder the module down, put a bunch of supporting circuits around it, take that through testing, take it through certification, and then you can go build your product or device some months or years down the road. With the GeoTraq modules, they're self-contained. It's all connectorized. So our tracker module has two connections on it. You connect battery to it, and you connect an antenna to it, typically an embedded antenna designed to go in a small device like you see here on the screen with a GoPuck. So when we started working with GoPuck, we were able to find some available space inside the existing GoPuck structure without having to redesign it. And we're able to insert our module, insert an embedded antenna. And in reality, our engineers had it connected to the Internet of Things within 10 minutes, really. So that is the paradigm that we're trying to create, to connect massive amounts of devices to the Internet of Things. It can't take months in years and can cost tens and hundreds of thousands of dollars to do it. Companies need to have ideas that if we could see where this device is, we can accomplish that quickly and move forward with operating a more efficient business instead of spending all our time on R&D. So Polte was a match made in heaven for us. Our tracker module really could be called the Polte module because all it does is run a mobile IoT stack. It runs Polte stack for location. And with that combination, we have a module that's 16 millimeters by 12 millimeters, self-contained, attach battery, attach antenna, and configure it to begin communicating to your backend system. So it's a great partnership, and Ed would love to explain a little bit more about how Polte provides that magic to us.
Yeah, sure. Thanks, Pierre and Blake, for teeing it up. It's great to hear all the amazing use cases that we're enabling out there. Polte, we met GeoTraq. It's been well over a year now when we first met, and Pierre was obsessed with this vision of this really small, low cost, super power efficient module that was really going to disrupt the whole IoT space. And we were like, wow, this is perfect, right? Because we think what we enable is to help him keep those boxes checked, yet still add great location, differentiated location everywhere. So what Polte is able to do is, with folks like GeoTraq, just through a firmware upgrade, add location. And beyond that, it's outdoors, it's indoors, it's even when that thing is enclosed. So if that GoPuck happens to be in somebody's backpack, right? If that was GPS, you would not be able to find it because there's no line of sight to the sky. The other option would have been something like Wi-Fi. You might get connectivity sometimes in a park, but the second that leaves the park and away from the Wi-Fi any sort of Wi-Fi coverage, you have a lost GoPuck, right? And so what Polte has been able to do is leverage the power of mobile IoT in the form of things like narrowband IoT and CAT-M. These are new cellular connected device connectivity options that are derivatives of 4G and 5G technologies that we're all used to with our cell phones, but enable a lot of the things that Pierre and Blake are looking for, which is that super low cost, long battery life, and then together with Polte, being able to still keep that low cost and long battery life, yet add a great location.
Thanks, Ed. As I was listening to the conversation, I understand the point about GPS and that if a device doesn't have line of sight to the sky, it's hard to locate it. I get that. What I was very surprised by, Pierre, and this is probably just my own ignorance, was the cost that GPS represents to the actual bill of materials for a device, and also the cost in terms of battery life. I was under the illusion that GPS chips are being produced by the billions, and they would be almost nothing, and that because GPS is just a receiver, it doesn't have a whole lot of drain. So could you actually elaborate on that a little bit?
Yeah, and there's a couple types of implementation with GPS. Many of the chipsets that are available today to build into modules have the ability to do GPS or GNSS. But there's always a burden for some additional circuitry. One of the ones that compounds things is the antenna circuitry. So generally today, when you're using GPS in an embedded configuration, it's a small patch antenna. For us, that patch antenna is twice as big as the size of our module. So it was a non-starter for us to try to be able to implement that. GPS is a receiver, but it's very processor intensive. The algorithms that run require a lot of computing time. Generally, I use a rule of thumb. If you've implemented GPS in, you're probably going to see up to 25% reduction in battery life simply running the GPS. From my perspective, working with Polte, it's not really necessary. So for me to have communications, I have to communicate on the LTE network. So the cost and size and power consumption required to do that is a necessity for communication modules. The fact that I can do location on the same LTE radio channel allows me to eliminate all of the other components and all of the other power consumption. So this is really, I think the industry is just really starting to take note of the fact that you can do location and provide good accuracy without actually adding anything to it. So we want to make sure that the modules we build, it's a requirement for us from a size and power consumption and reducing costs, that we take advantage of position on LTE, which is what Polte stands for, by the way. And that if customers feel the need to have GPS, we can interface GPS receivers as a sensor into our module, but we don't see a lot of customers talking about doing that once they see what Polte's capabilities are.
Excellent. So then, Ed, you mentioned that just to add the Polte capability, it's just a firmware upgrade. So, Pierre was just talking about the processing burden that GPS places on the module itself, and so not just the antenna, but also the battery life and the draw there. How does Polte overcome that if you're providing location as well? So how come that you don't have to have such a burden?
Sure. So what we do is, although we are a firmware upgrade to the chipset that's in Pierre and other, in Pierre's module. And what that firmware does is it's just taking standard radio signals that have been demodulated from the cellular network around it, and actually sends that information compressed, a couple hundred bytes of data to the cloud. And so by sending it to the cloud, we then we're offloading the device from all that computational complexity of computing location. Computing location, as you can see in GPS, it's a lot of MIPS and a lot of memory to do it. There's lots of math. And what we do is we put that math in the cloud, and what that does, it allows the chip and then the module to not have to carry that burden and and have that type of compute power in it. The other advantage of that is it can continuously improve, right? So through we have the ability to see the environment, adapt to the environment that the device is in, and over time also learn and train based on crowdsourcing, machine learning algorithms to continuously improve, right? So if it was a piece of firmware that was fixed or a piece of hardware that was fixed in that device, you're kind of stuck with an implementation. So the power of putting things into the cloud, having this chip to cloud type architecture, allows us to do those two things. One is offload the device and keeping that device low cost and low power, but also be able to continuously improve that capability over time.
Okay, excellent. So then one of the advantages that you have then is that it works, in addition to the advantages of simplifying the device itself, it works indoors. I don't think you have the ability to, so I'm looking at one of the questions that came in around tracking elevation. Can you tell which floor it's in? You probably don't have that optimized today, but I would imagine that that's something that could be developed over time. Is that right?
Yep. The first focus is, let's just find where it is, right? So are you at this address, or are you on the road? Are you still in the venue, right? Have you left the venue, right? That type of accuracy and XY, we think, is important for pretty much every use case. We do have a roadmap that allows us to bring in Z-axis in multiple ways, whether it's network-based location or other to tune our algorithms to be able to handle height, especially in urban areas when you have tall towers. So the nice thing about that is over time, what we'll be able to do is take advantage of the height diversity of antennas, not to get too technical on it, to be able to kind of turn our algorithms 90 degrees up and from horizontal to vertical. And that's something that we have in our roadmap. But initially, the focus is around XY, and then we also have partners that can supply Z-axis solutions if you need it today.
Okay. And then another question that's coming in, and by the way, please do keep the questions coming. We appreciate this. It says, does Polte use wireless cell site triangulation or hybrid of wireless cell site triangulation as well as Wi-Fi?
Yep, we are 100% cellular based. So what we're doing is, in essence, triangulation. That's kind of the fundamental core of most location systems. But what we're doing more importantly is the real innovation is we're actually taking we're listening to all the cell towers that are in a particular area that you're in, right? So we're able to see 2, 3, 10, 20 cell sites sometimes. More cell sites, the better. And then we're able to use our super resolution algorithms to get rid of a fundamental problem and source of error for that triangulation algorithm, and that is multipath, right? So if we're able to estimate the line of sight distance from known cell tower locations to that device's location, get rid of multipath, which becomes error, using that super resolution technology to do that, gets us to the point where we're able to have the most precise and accurate location using cellular.
So in that question, the topic of Wi-Fi was raised, and this is to all of you, whoever would like to answer. We're talking a lot here about mobile IoT or cellular IoT. What do you guys think about Wi-Fi and its place in the whole world of IoT? Whoever would like to answer.
Yeah, I'll offer something on that. So it's, you really, and we spend time with our customers trying to understand what their use case is. So when we look at in GoPuck's scenario, they don't know where their devices are going to be. They're rental devices, and they move around and from day to day and within the day. So it's very complicated to develop a business model where you don't know if those devices are going to be in coverage. And that's really a limitation with Wi-Fi and some of the other industrial ones, Bluetooth Low Energy, Zigbee, and Z-Wave. If you have a lot of connected devices in a small area, you can build your own network and manage it that way. And for people, there's some solutions where that makes sense. But when you need to be able to have connectivity over a wide area, that becomes very difficult to manage. So we talk with Blake about some market segments that we're going after: international shippers and freight forwarders and third-party logistics companies. They want to be able to track packages in near real time. As you build more sophisticated logistics processes, just in time becomes very important. And there's a cost to not having parts arrive where they need to be when they need to be there. So having the comfort of a global mobile IoT network provides some benefit that allows those processes to work and not really have times of day or blind spots when they don't work. So Wi-Fi provides a great solution if you're sure your connected devices are within the cloud or a cloud you have access through the firewall, and can communicate that information. The way that Polte uses it, I think, is great. They help use that information to augment their algorithms for the LTE network and make that more accurate. So we're not really, we just see there's a specific use case for a specific wireless technology. Sometimes Wi-Fi is the right one, and in a lot of cases it's not.
Yeah, and if you don't mind, Daniel, I'll jump in a little bit on that too, from the costing standpoint, from a customer standpoint. And that is that when we looked at Wi-Fi as well as Sigfox, LoRa, there was some distinct challenges we came up with. One of those with Wi-Fi is that in some of the venues, while there is a ubiquitous Wi-Fi maybe provided by a local cable provider, what that meant is that we were putting all of our eggs in that one basket for that cable provider to provide location service with a little bit less accuracy. The other challenge is that if we wanted to use the venue's Wi-Fi, that was not within their privacy policies and their acceptable terms, so that became a challenge. And then if we wanted to use our own hotspots or create our own Wi-Fi network, then we're looking at additional costs that are there. And we ran into that same problem because one of the things that drew us originally to kind of wideband would have been the ability that one gateway could serve, say, thousands of our devices. And really the topic of, empowering billions of devices is really what we're talking about. And at first, we looked in a very micro environment and said, wow, this is great. We could have thousands of GoPucks in one area with a low cost per device for tracking. But then what happens when it goes out of not only the geo fence, but the reality of our own self-propagated network? And that's where we started running into challenges, is that there were some usage cases where we'd have to have a pretty high capex and build out our own network, and we might be able to share it with others, or we could piggyback. But when we look at the amount of investment going into LTE and the amount of investment that is going to keep that live and is going to scale with the demand for the next billion devices, not just in the IoT space, but also the next 4 billion people being connected globally. When you look at mobile to mobile, it's really exciting to really be looking at the software and firmware aspect of it as to how to empower that, as opposed to really becoming a company within a company, suddenly having to build your own network. It's just so much easier to piggyback off of, as they say, standing on shoulder of giants.
Yeah, I just from my own experience, actually, I would agree with that. The cellular networks are designed to be multi-tenant shared networks, and when we look at and they're global, and when we look at things like Wi-Fi or other local networks, they're not global. Many of them are not meant to be shared and public networks. And then if you look at others like LoRa or Sigfox or whatever, they just don't have the reach. That's my personal opinion. So one of the other questions that came in here online, and I think this one is for you, Blake. It says, I'll read the question. It says, what else can I track? Can I, for example, track the temperature during the route of the puck? Any other sensor data besides XY location?
Yeah, so I think I'll answer half of that, is that ultimately for us, with our current devices and then our roadmap of devices, adding in additional sensors allows for us to environmentally know more about the type of conditions of the ultimately the battery, the lithium ion battery, or whatever chemistry it is. And batteries are very much like humans, back to the Internet of Nouns, is that humans don't like really cold weather. We don't like to go to work when we have to shovel snow. And we really don't prefer temperatures above 100 degrees Fahrenheit because we start sweating, we feel lethargic. And interestingly enough, a lot of battery chemistries that are in use today have similar operational windows. They can work at a little bit higher temperatures than humans can, but when it gets cold, there's a degradation. So for us, understanding the environmental conditions of where our products will be used as they travel around the world is very important. In our design, as every design, there's compromise. So with our current products to market, we have one of the widest temperature operation windows along the line with like a mil spec product. So they can go from -40 Celsius to 140. But the reality is that for our standpoint, having that additional data, barometric pressure as well, which kind of leads a little bit to the altitude question. But all of these type of factors really do influence our design and also serving our customer. Plus, it validates from a warranty standpoint and a customer experience standpoint, because then we can get to root cause analysis of why something is not performing to an expectation of the customer. So hopefully I touched on that. I don't know if that was as specific as they wanted to know, or if they.
Yeah, and I can, if I can add in a little bit of comments on that. So when servicing the Internet of Things, sensor interface is a very important part. So we're actually developing a couple product lines. One is our tracker module, which is really only for location. We're also in parallel developing a sensor module, still utilizes Polte for location stack, but has the ability to interface to external sensors. Sometimes those external sensors are actually built into the housing of the device. And then there's a whole industry that external sensors means cables that run some distance and connect to existing sensors or distant assets that need to be tracked. Our market information says probably 30 to 40% of our customers only want sensor information. They're using the modules to connect fixed sensor locations. So the locations is not as important to them. They know where it is. It's bolted down. But being able to bring back the sensor status is a very important attribute of that. So GeoTraq has two product lines, one location only, one with location and sensor to be able to service the entire IoT ecosystem.
Right. You know, I would just from my own experience, I would say that yes, you know, lots of people talk about sensors and extracting all of this data, whether it's temperature, vibration, current draw, you name it. But as we look to process that data, the context around that data can be important, and location can be a very, very important context. If something's vibrating because it's going down the road, well, maybe that's okay. If it's vibrating and it's supposed to be indoors and nailed down, that's probably not okay. So just having that as just again knowing where something is, I think is critical. Any comment on that?
Yeah, I was only going to emphasize, absolutely, it's what we're doing, and you know, Blake has a great use case, but Pierre has lots of customers that we've been seen, and lots of different use cases out there that are addressing lots of different things, right? So using the being able to use those IoT devices to transform businesses, provide better user experiences for consumers. It's really fundamental, right? Just that it's being able to provide insights that are driven by those sensors of the environment, whether it's vibration, temperature, humidity, or light. Adding location, to your point, Daniel, only gives an extra context of time and space to that data, right? So I now know how to solve a problem with the distribution, with the distributor, or I can do things to improve my supply chain. If temperature of a truck goes above a certain level, I can make sure that truck then can remedy, that problem, right? If I have, temperature sensitive compounds, or if it's alcoholic beverages like beer, people don't want that to go above 50 something degrees. And by having those sensors of temperature and triggers that are based on those triggers, but then knowing where they happen and when, allows you to take action, right, to improve it, right? So it's more than just knowing it, but it's actually now knowing it and being able to do something with it.
Yeah, and if I could just one more comment in there, Daniel. Sensors become, you mentioned, long battery life. Sensors become a very important part in that, particularly as an example, motion sensors, right? So even in assets and packages that are moving, so you want to have those report their location so you can keep track of where they are. But generally, assets go through periods throughout the day or throughout the week where they don't move. So if you're trying to track the location of an asset every hour, but it sits still for 10 hours during the day, there's no value to having it report once an hour. So the combination of motion detection, it reports in. If you get a couple of cycles where it's reported in and using Polte, it hasn't moved, then you just put it into a deep sleep state. And the next time it moves, you wake it up and it begins reporting again. So when I mentioned earlier, it's a multi-level attack plan to be able to get that long battery life. Those are the types of things that you need to be able to do in order to realize that.
Right. One other question that just came in here. This one is for you, Ed. Does the Polte technology work in Europe where cellular networks are not?
Sure. It does. We have the ability to work in synchronized and non-synchronized networks. There's certainly different things architecturally that we need to do to help unbiased that the possible lack of synchronization in certain countries where they may not be using either satellite-based synchronization or the like. But what we are finding, though, as people are migrating to 5G, the requirements of the standards are requiring us to get to those networks down to really, really tight timing. And there's a lot of great innovation in the standards right now that are driving that into the future. So we see that we already see a number of countries in Europe that are already synchronized. They are getting there, and a lot of it is to be able to support 5G in the future, right? And the cost of being able to do so has come down significantly. So if you have a synchronized node, you can actually leverage network-based synchronization across that single node that just through firmware upgrades to the network infrastructure. So it's a great question for this panel, but it is something that we are very aware of and have solutions for.
Okay, I'm conscious of time here, but I'd like to just touch on something that you mentioned there, Ed, which is 5G, and I'll throw this out to the panel. What do you see as the challenges and opportunities of 5G?
Yeah, I'll add in that. So one of the things that we're glad to see is the governing body G3P has moved the narrowband IoT and CAT-M network connectivity standards into 5G. So we expect to see continued evolution of those capabilities in 5G. Probably the biggest value is, the advantage of working with the cell networks and mobile IoT networks is we have some very large companies that spend billions of dollars providing capacity, providing in-building penetration. And 5G is only going to drive that forward. They have lots of business opportunities, but we get the benefit of them literally bringing those networks everywhere. It's the foundation of their future business plans to provide that 5G coverage. The more that coverage expands geographically and expands in penetration into buildings and all areas of buildings, only makes this location technology work better. It just reaches and touches more places. So as you mentioned, cost is an ultimate driver for adoption here. 5G is the newest and latest and greatest, right? So chipsets there can be a little bit expensive. But as those enormous economies of scales take hold, those chipsets will come down, and we look forward to adopting at the appropriate time for cost and performance in the future.
I'd only emphasize what Pierre said. The GSMA and 3GPP have defined NB-IoT and CAT-M, which are branded as mobile IoT, as 5G compliant, right? So IMT 2020 spec'd both the high speed, thing that you read in the paper today all the time where 5G, a lot of 5G phones are going out there. That's based on what's called NR, which is super high bandwidth, high capacity. But these other profiles of 5G that are specifically tailored towards massive scale of low cost battery and battery powered devices is another profile within the 5G's family of standards called NB-IoT and CAT-M, collectively called mobile IoT. So for folks like Blake and who are adopting mobile IoT devices today, they can rest assured that they're going to be supported for a long, long, long time to come because you've got this huge industry around the 3GPP standards there to support you.
Yeah, and from my end, I take a little bit different take, is that 5G is very exciting because that means that more and more enterprise level solutions are going to come into the mobile environment. And so we're partnered also with OtterBox in providing not only power, but protection and solutions for enterprise customers. And so whether it be a handheld device or a mounted device or even a wearable smart glasses with one of our other customers that has a lot of growth in their market, having that additional speed of connectivity is going to drive the amount of utilization, both for consumer and enterprise, which of course, all of those rely on mobile power, which is good for business. So from my standpoint, it's just going to drive up the demand for battery powered solutions. It's going to drive up the demand for efficiency in the battery segment. And of course, back to why this all matters is that when you're powering those billions of devices, the more mobile those are and the more that they're on the edge of really that handoff from the person to the place, it's really where we're going to need a lot of efficiency, and these type of software solutions really do drive that.
Excellent. One last question I think we'll answer, and then we'll try to wrap up. There are several questions that we've left unanswered here, but we will follow up by email. But just one final one. It says, is Polte location technology? Sorry, is Polte location accuracy range varies today between urban versus rural transit routes? So I think the question is what is the relative accuracy of urban versus rural?
Short of it is, yes, there is variability, but we give you accurate location where it matters, right? So we can help you find the things that matter where it matters, right? So when you're in urban and when you're suburban, we're able to get excellent accuracy, something like with a Cat-M device, sub 50 meters, 20 to 40 typically. When you're in the rural areas, obviously the geometry of the cell sites are much larger, right? In some cases, when you're on the highway in the middle of the U.S. or in the outback of Australia, you're going to have cell sites that are tens of kilometers apart. And so being able, just through that geometry, you're going to have less accuracy. But in most use cases, they're going to want to know that, hey, I'm just on the highway and I'm moving down the highway. And being able to be in the couple hundred meter range is good enough. Right, so that's basically what we're finding. But there is some level of variability, but we're able to provide accuracy where we think it matters most.
Yeah, and if I could just add some comments on it, it's important to watch what the use case is. So engineering is the science of compromise, right? So one of the ways that we can reduce the cost and the size, the power consumption of our modules, as we described earlier, is taking advantage of position on LTE. We understand there's use cases out there that require, meter level accuracy, and that's fine. If you need to have that, if your use case really requires it, you incur the GPS penalty. You pay $3-4 more for components. Your device gets bigger because you add components and patch antenna. Your power consumption goes down. If that's what the use case requires, then use it. But we find with many customers, as Ed's described, when you really talk them through what the use case is, even in the rural areas where the accuracy may degrade a little bit, hundreds of meters if you're trying to find a trailer or a generator, an asset out in the countryside in Wyoming, you're still going to find it, right? So that's what we encourage our customers to do when we talk to them. Don't add cost and expense to increase your level of precision if it doesn't add any value to your use case. And 9 out of 10 times, we find that people can see the paradigm shift in that. And that's one of the things that's going to make this technology takes off, is we get it implemented quickly, we get it implemented inexpensively, and it works very well. And that's what's going to allow the market to accelerate growth.
Excellent. Thank you, Pierre. There's one quick question, which I'll answer myself. I don't know if it's being addressed to Blake or to Pierre or to Ed or to everybody. It says, when will this be ready for market? And the answer is today. So, this is technology that we're talking about that is available and is proven and can be taken advantage of. I'm going to wrap it there. My sincere thanks to Blake, to Pierre, to Ed for your inputs. It's been an excellent conversation. I think it, and correct me if I'm wrong, but I think it validates the thesis that I started here with at the beginning. And as we speak about sensor data, I think it proved that people are talking about all sorts of things with the Internet of Things, connecting billions of devices, but there are fundamental things that we absolutely must make sure we take care of. That's the cost of the connection of the devices themselves, the cost of the modules, the battery life, and being able to track devices. So I'm pleased that my thesis is true, or at least has been validated by panelists. For each of you, any last comments before we wrap? Blake?
We're good. It's been fun to be a part of this, and from our standpoint, it's great to have technologies like this come alongside, so that we as a company don't have to develop it. We can focus on what we do best, which is the battery technology and powering the devices, be they mobile or stationary, especially in remote locations. So it's great to not have to build out another business development arm of the company and to have the experts in the field do it.
Excellent. Thank you. Pierre?
Yeah, the only thing I'd add is just encourage people to simplify what they're doing. Many IoT solutions that we've seen in the market today are extremely complex, difficult to deploy, take a long time, cost a lot of money. We operate at the other end of the spectrum at GeoTraq. Our goal is to make it easy to deploy, easy to use, and we encourage our customers always to simplify what it is that you're trying to do and get into the market faster. So that's what I'd like to leave with.
Okay, excellent. Thank you. And Ed?
And I'd just like to say thank you to Pierre and Blake for joining us and being great partners, and really bringing to life our vision of being able to have a great location just through firmware upgrades to cellular modems. Being able to, in essence, provide what is the next generation location platform beyond what is known as GPS, right? So we think that we can really revolutionize together what's possible with IoT. So, and thank you, Daniel, as well.
My pleasure. And to everybody who participated, thank you very much for your participation. Thank you for your questions. I hope that you found this valuable. Feel free to send in any feedback, and we look forward to more sessions like this where we can delve into other aspects of the great world of IoT. Thank you.
Thank you.
Thanks, Daniel.
Thank you.